All right, so let's talk about the microcontroller or the Wi-Fi chip. Now, I'm using something called ESP32. And for those of you who are new to the world of microcontrollers, um, this is a crash course on what a microcontroller or an MCU is. So a microcontroller is basically a tiny computer that can be programmed to do anything. And the one I'm using for this project is called ESP32. ESP32. And if you just type this on Google, the decision you get is ESP32 is a series of low-cost, low-power system on a cheap microcontroller with integrated Wi-Fi and dual-mode Bluetooth. So as tiny as this guy is, I don't know if you guys can see this clearly. As tiny as this guy has Wi-Fi and Bluetooth inbuilt of it. So it means that I can program this guy to connect to my Wi-Fi network, publish information to the MQTT broker we just installed, right? And any other device on that network can take that information that this guy has published. So I actually have two of this guy. I have this one, as you can see here. I also have this one you see that I have on the breadboard here. Now, how do I intend to use this guy to control things like my fan and my wall socket? It's very simple. Now, this guy has some pins here, as you can see here, right? These pins are called GPIO, general purpose inputs and output pins, right? And these pins can be used to control things like relay, and relay can be used to control things like AC appliances. Now, I'm not going to go in depth into that for now. I'm going to create a separate video for that, but the takeaway here is that I'm using ESP32 because it has inbuilt Wi-Fi, and I need Wi-Fi for what I want to do. All right, so now let's put that aside. So we have ESP32, we have our broker installed, we have Tony installed, we have Visual Studio installed, we have Explorer installed. Let's get into business. And there's one more thing we need to download. So in order for us to program this guy, we need to install what we call Micropython inside of this guy, not on our system, but inside this guy. So by default, these guys are designed to be programmed using C++. But we want to use Python to program it, so we need to install Micropython inside of this guy. So Micropython is like an operating system, actually. It's not an operating system, but it's like an operating system that can be installed into this tiny computer in order for us to be able to program this tiny computer with Python or Micropython. So go to your XAR and then just type download Micropython, and the first link here. Scroll down, look for ESP32 here. So there are two options actually. You can either download this particular version or download this one with OTA support. Now OTA stands for on the air. On the air means that you'll be able to program with this particular version of Micropython. You'll be able to program the chip via Wi-Fi without having to plug it into your computer. But that is not necessary for now. So I'm going to go for the regular Micropython here. So I'm going to download this particular one here. So I'm going to click on this. It's going to give me a list of release of versions, right? Just download this latest version here. So download that and then just leave it on your system for now. I'm going to show you how to use it. Yeah. All right. So let's start by. So we just downloaded the Micropython. The next thing we want to do is to install Micropython into our ESP32. So what you need to do is to just get a USB cord, connect it to your system, and then plug it into your microcontroller like this. Simple as that. Then if you have that connected, you can open your Tony. Remember I told you Tony is what I want to use to program our microcontroller. So now that you have Tony opened, what you want to do is this. You want to go to run, go to configure interpreter, and this place where it says which kind of interpreter should Tony use for running your code. All you need to simply do is to click the drop down, the button here for the drop down, and then click on Micropython ESP32. Now, this place that says ports or WebREPL. Now, if you're using WebREPL, basically you want to enter the IP address. Let's just keep this for now. Actually, and this is just all you need to do is to click on this and then select CP210 USB. Now, in case you are wondering why I selected that particular option, actually this is showing us all the ports that are currently available on my system. So COM6 and COM67 here, actually you can see is just the Bluetooth on my system here. But this is the only strange man or the odd man house, right? So technically this is my ESP that is connected. So if I remove my ESP, that port will actually disappear. So if you let's cancel this. Let's go to run, configure interpreter, ESP32, and then if you click here, you can see that that port is gone already, right? So the port is only there because my ESP is connected to my system. So that is an indication that that port belongs to the ESP. So let's plug back the ESP. And then that port should appear back. So we might have to cancel this again. Go to run, configure interpreter, select ESP32 Micropython. Then now the port should be visible. So let's click on that port, and then before you click on OK, because this is the first time you're actually using this is a brand new ESP, right? So I have to first install Micropython in it. So there's a button here that says install or update Micropython. So you click on that. Then you choose the port again. Then now choose the firmware. So you click on browse and then go and select that ESP32 Micropython bin file you just downloaded from Micropython, right? So this is it here. Click on that. Click on open. Then ensure you have this selected, erase flash before installing, and also from image file. Then click on install. Now, one thing I noticed about this installation is that if you're on Windows, you might need to hold the boot button down. So there's a button here that says boot. There's a button here that says boot. You have to hold that button down first, like this, before you now click on install. Just hold that button down before you now click on install. So I noticed that if I don't do this on Windows, it doesn't install successfully. But when I'm on Linux, on my Linux laptop, it actually installs without me pressing the button. So you can leave it when it's already showing things like writing. So as you can see here now, it says 6%, 7%. I want to wait for that to be installed. Alright, so while we're waiting, so basically, just a reminder, what we are doing is installing Micropython on the ESP32, and this allows us to be able to program the ESP32 with Python, because by default it's meant to be programmed in C++ or C. So now one more thing I noticed is that sometimes if for any reason you click on ports here, right, and you didn't see the port for the ESP, you might need to install something else, which I'm going to show you once this is done. So let's just wait for this to be completed. Yeah. So yeah, installation is done. Then you can click on close, then click on OK. Now the moment you click on OK, if everything works out fine, you would see in this section here called the shell, You'll see something that says Micropython, the version of Micropython, and ESP32 module with ESP, blah blah blah. So we'll come back to that shortly. But I want to show you something. So just in case of when you go to configure interpreter and for some reason you can't find the port here, maybe you can't see any port here at all, or the port you are seeing is not the port that belongs to the ESP. It's possible that you don't have the drivers for that ESP installed in your system. So what you want to do is to cancel this. You want to go to tools, go to manage package, then here you want to type CP2 and then just search, and then install this Silicon Labs package here. Just click on it, and then once it loads, just click on install, and that's all. So once you install, restart your tuning, and that should allow your system to actually see the ESP. That's if the system does not see it by default. Alright, so now let's come back here. Ensure you have selected the right interpreter, ESP32, Micropython, and then click on OK. Now if everything is fine, you should see this information on the shell. Now, what we are currently seeing right now is a shell access to the ESP32. Now, for those of you who are familiar with using command prompts or using a Linux shell, I'm familiar with the concept of shell, right? It's like a command area where you can type commands, right? And the computer can execute those commands. Now, the only difference is that this shell you are seeing right now is not for me to execute commands on my computer, but to execute command on the ESP32. So I'm currently inside the ESP32 right now. So if I type something like print hello world here, and I press enter, it's going to run that code. But this code was not executed on my laptop, or was it? It's not executed on my system. It was executed inside this guy. And let me prove that to you. If I remove this, let me disconnect this. Can you see what happened? It says connection lost. So that shell I was typing in was actually, whatever thing I typed inside that shell, actually going into this guy. This guy is executing that command, and then the command is sent back to my system for me to see. So let's connect this back. Then we might have to click on stop here to restart the backend. You can see I'm back to the ESP now. Good. So I just need to make that clear. Now, alright, so that is how you use the shell of the Micropython to write direct Python command and expect results from the ESP. But that's not how we're going to be programming the ESP. We need to write code that can actually live inside the ESP and be executed anytime the ESP comes up. So how do we go about that? Something I want to show you guys. If you go to file and if you go to open, it's going to ask you, do you want to open files on this computer, or do you want to open files on the Micropython device? It shows you that inside this guy, there's actually a file system inside this guy where you can actually save files. You can actually save things like TST files, Python files, JSON files, any kind of text file, basically. So click on Micropython device, and you will see that there's already one file inside the device already called boot.py. So what happens is this: whenever you plug this ESP into a power source, right, what the ESP does is that if the ESP has Micropython installed, right, which we already have that installed, what it does is that it looks for a file called boot.py in its memory, right, and then immediately starts to execute that code. Now, once it's done executing the boot.py, it looks for a file called main.py and begins to execute main.py until it executes main.py finish. Now, if for any reason there is no boot.py in the memory of the ESP, then it just goes straight to execute main.py. So you need to know that you are meant to rename whatever file you put into the ESP has to be renamed as boot.py or main.py. Now, this is similar to, if you are familiar with Arduino programming, this is similar to void loop and setup loop. So in setup loop, you write codes that you want to use to set your microcontrollers, and in void loop, you actually write your main loop, right? So in this case, we're going to write our setup code in boot, and then our main code in main.py. But for now, we'll just use boost.py alone, which would also work fine. So I'm going to click on that and open it. You will see that basically there's actually nothing here, it's just some bunch of comments. So it says that this file is executed on every boot, including the wake boot from deep sleep. So let's remove all this. So what we want to do now is to do something interesting. Now, if you check this ESP and you take a closer look at the ESP, you will notice that there's a LED chip here, right? And that LED chip is actually connected to one of the pins here. It's connected to pin 2. So just to confirm that, the ESP pins are actually named and numbered. They have numbers and they are named. And if you scroll down to this table here, you will see it has 0 to pin 39. So, and each table have information about each of those pins. So we have what we call the inputs, the outputs, and the nodes. So what we are looking for is the pin that connects to the onboard LED, and you can see that here it says that pin 2 connects to the onboard LED, right? And another thing we need to confirm is that this pin also actually supports using it as an output pin. So an output pin that means that we want to use the pin to send a signal. In this case, we're using the pin to send a 5-volt signal to the onboard LED, so the onboard LED can come up. So what we're trying to do actually is to blink that LED, turn on and turn off the onboard LED. So we've confirmed that it's connected to pin 2, and also confirmed that it supports outputs, right? There are other pins that support output. If you scroll down, you see that from pin 12 to pin 33 also supports output. However, none of those pins are actually connected to the onboard LED on this controller. So now let's come back here. So what you want to do is to import. What you want to do is to import a library called machine. Or let's do this way. Let's say from machine import. From machine imports pin. From machine imports pin. Then we can say LED equal to pin, open brackets, pin 2, which is the pin we want to use. And then I'm going to explain this pin dot out. Now what I've done here is this. I've imported the inbuilt library in Micropython called machine, and from that library I'm importing a class called pin. Now that class allows us to create an instance of a GPIO pin that can be used to do whatever it is we want to do, either as an output or an input pin. The next thing we want to do is also specify the pin number and what the pin wants to be used for. In this case, the pin wants to be used as an output pin, right? An output pin. Sorry about that. Yeah. So the next thing we want to do is to turn on the pin. So let's say LED dot on. Now take a good look at this ESP. Currently the LED is turned off. The moment I press play here, it executes that code and the LED comes on, as you can see here. So if I want to turn this to off, it also executes that code and the LED goes off. Now one thing you should notice is that the moment you click on play here, it actually saves this code inside the ESP as boot.py, because that's currently what we are editing right now, as you can see here. So it means that the code now lives inside the ESP, and anytime we restart this ESP, it's going to execute that code. But in order to make this more interesting, let's make this a blinking code instead. So I'm going to say while true, and I'm going to say, first of all, turn off the LED, sleep for 1 second, turn off the LED first, sleep for 1 second, then turn it on, then sleep for another 1 second, right? And so we're going to keep repeating this. So we also need to import time. From time import sleep. So the truth is that if you are familiar with Python already, then Micropython is going to be something that's going to be very, very easy for you. It's basically the same syntax, the same code. The only difference between Micropython and Python is that Micropython is is lightweight, right? So there's some library that you find in normal Python that you would not find in MicroPython. So that's the only disadvantage. So MicroPython is like a subset of Python. So everything you can do in MicroPython, you can actually do it in Python, right? So your syntax, your conditional statements, your rules in Python also applies here in MicroPython also. The only downside is that you are limited in terms of inbuilt library. However, you can always create your own library yourself in MicroPython, which I'm going to show you. Eventually, I'm going to have to create a library for this guy. So now, let me run this code, and this should blink. If everything is fine, this should blink our ESP. Is it blinking? Yeah, it is. So that's how you write a blinking code for your ESP using MicroPython. Now, just to prove to you that even after power on or reset, this guy still runs this boot code. I'm going to remove this power here, and then this time around I'm going to power the ESP using my power bank. So I'm going to plug this here and then connect this to the ESP, and if everything works fine, you should see the code blinking. So the moment the ESP comes up, it sees the file called boot.py and begins to execute that file. So once we are done uploading our code in the future, I'm going to just take this thing and just put it into the device we want to put it, so the device can use this guy to communicate. So in the next tutorial, I'm going to show you how to program this guy to publish and subscribe to the topics on our MQTT broker. But for now, I think this is a good start.